Cool. Python. Today we're going to talk a little bit about what it means to code Pythonically. We're going to learn the basics of Python, especially when you're transferring your skills from languages such as C and Java, which are commonly taught here, to Python. And at the very end of this, we're going to kind of put all our knowledge together to make a Hangman game somewhat Pythonically. Why don't we go to the next slide, Alex? So, who are we? I'm Ryan. I'm a tech lead here at the Google Developer Student Club at UCF. One of my favorite hobbies is watching and playing basketball. Alex, do you want to introduce yourself today?
Yes, thank you, Ryan. Hello, everyone. My name is Alex. I'm also a tech lead at the Google Developer Student Club at UCF. I'm a student majoring in computer engineering. And if you guys remember me from last month, I was part of the Intro to HTML and CSS and JavaScript workshops. So if you weren't able to assist to those, go check that out on our website.
Yeah, that was a phenomenal workshop hosted by Alex, which was on our YouTube, and you can still currently see it on the DSC YouTube. Next slide. In addition to today's speakers, there are supposedly two moderators in the chat who will be answering your questions, Ethan and Max. At any point in today, if you have a question regarding some of the concepts that are being brought up or any questions about what we're doing, feel free to leave your question in the chat and we will answer it appropriately. And let's talk about a little bit about today's environment. We're moving a little fast here. So I remember earlier in the announcement, we told everyone that it is recommended that you install Python on your local environment. But for today's time's sake, we're going to use the website repl.it, Replit. And what Replit is, it's just an online IDE. If you look at this picture in the bottom left, you can kind of see how it works. All you can do is type your Python code in the little space, and you can click run and run your Python code really easily. Today, for demonstration's sakes, we are going to use REPL in order to show off code and learn Python together. For those who have not worked with REPL before or do not have an account, the link is right there on the screen, repl.it. Feel free to make an account. It's very fast, very quick. And we're going to give everyone 2 minutes in order to make an account for those who don't have an account in order to get loaded up. So we're going to wait 2 minutes. And for those who do have a REPL, I should also introduce this now. I'm going to send everyone in the chat a link to one of the REPLs that we'll be working on today. When you click on this link, you'll be able to fork this REPL. It should be a big button when you click on this link. And what that basically does is that it just creates a new instance of the REPL on your own account for you to work on it and code along with us today. If anyone has not made a REPL account or still needs more time, feel free to talk in the chat or speak up. If not, I think it's free. We're free to go, Alex. So let's move on to the next slide. So let's talk a little bit about Python encoding and what it means to code Pythonically. For those who don't know, Python is one of the most popular programming languages across most developers. I believe it's like the second or third most popular. And many people who use Python are really attached to this idea of Pythonic coding. And it's a large reason for why the language is so popular. To put it shortly, Pythonic coding is exploiting the benefits of Python to produce clear, concise, and maintainable code. And this is the main feature of Python that makes it competitive and arguably better than other languages such as Java or C. So, as an introduction or kind of an example of what it means to code Pythonically, we have some code snippets on the right here on this slide. And in these code snippets, what we're doing is we're just printing the numbers 1 through 10 on the same line and then ending on a new line. If you see this, if you were to do this in Java, for those who have taken an OOP course or CS2, you would know that you just run a loop from 1 through 10 with system.out.print, so it's on the same line. And then you print ln the last number, which is 10, at the end outside of that loop. I'm sure that you can import some packages, some Lambda expressions, etc., to make this even shorter in Java, but this is kind of arguably the main way that one does it in Java. If I also translate that code snippet into just pure Python, you'll get what we have below that. And we're going to talk a little bit later about what these functions exactly does and what each of these little lines mean in Python. But as just a little preview, you can tell that the syntax in Python is a lot more shorter and concise than its Java equivalent. But this is still not coding Pythonically. If you look at the very last code snippet at the bottom, we can print out the numbers 1 through 10 using the same exact, just like the two code snippets above, but all in one line. And this is truly what Pythonic coding means. You are exploiting the benefits of Python so much that you're able to fit this logic all in one line and to have really clear and concise code. So with that, why don't we move on to the next slide? Alex, are you able? Okay, cool. So we're going to get started immediately. And for those who just came in or just dropped by, there's a REPL link in the chat, which will take us to a REPL for us to work on kind of these small exercises in order for us to get introduced to the language. And for those who have not worked with REPL before, all you have to do is click the link and click fork this REPL in order to get all this code here. Now, this is mostly not code, but all of this are a bunch of comments in Python and in practice, a bunch of practice problems for us to kind of learn the language together. One thing that you'll note almost immediately, then Python will use these hashtag symbols or pound, whatever you want to call it, in order to symbolize comments. This is different than C or Java, which uses the 2 backslashes. So the first prompt that we have here is to declare a variable, print it, and change its type. So in Python, one of the coolest features is that everything is untyped, meaning that if I was to create a variable now, so why don't we create a variable, Alex? Let's type var is equal to 7. And Python does support integer data types, which is what this 7 essentially is. And let's print it. And in order to print something in Python, all we have to do is to write print, open parentheses, and just plop in the variable name or a string if we want to print, some actual text. So why don't we run that to show them? Cool. As you can see, I'm able to print the variable var, even though I have not attached a type, such as integer, to it. And in order to really emphasize this point, Alex, why don't we change its type? So after our print statement, let's change var to a different data type. Why don't we change it to a string? Python does support string. So in order to initialize it, what we have to do is just use the double quotation marks, very similar to how you would do it in C or Java. So let's write GDSC. Let's make the var a string GDSC, and then let's print it. Let's run this. And as you can see, the variable var changed its data type without us ever having to reassign, and it didn't give us any error for changing its data type. In order to prove this, why don't we use the type function, which is a function put into Python in order for us to verify the type of each of these variables. So Alex, if you write the words type over the variable, in both of these print statements, Python would then spit out the data type of all these variables, even though from our perspectives, it looks like there are no types attached to these variables. So let's run this. And as we can see, the 7 is a class integer, and the GDSC string is a class str, which is just shorthand for string. So inevitably, Python does have these data types, but because it is an untyped language, we don't have to specify those data types and we can switch data types really easily by just reassigning the variable. Cool. Now let's talk about for loops in Python. So our prompt here is to create a for loop from 1 to 10 and print the value. So let's do that. In order to print a for loop, or in order to create a for loop in Python, all we write is for, and then we give it a variable, I. Let's use the variable I, in, and this in keyword essentially indicates to iterate through some sort of list-like component. So in this example, what we want to do is we want to give it theoretically a list. And what this list will have is basically everything we want to iterate through. Now, this might seem very confusing for someone who is unfamiliar to the Python language, because most of us are used to initializing a variable I to 0, and then just having an incrementer like I++ in order to increment it. Python works differently. Instead, we give it a list of numbers, or an iterable is what it's sometimes referred to, and it automatically increments itself through the list. So how do we create a list from 1 to 10, or how do we just run a loop 10 times? Well, Python has this really cool function called range. And if you write the words range right now, what you can do is you can pass it in a couple of arguments. And as you see here, REPL has pretty good documentation on what range does. But in essence, this is all we have to know for the sake of today's workshop. If you pass it in one argument, it creates a list from the number, or I should say an iterable from 0 to the number you passed in. So for example, Alex, why don't we put the number 10 here? And then let's put a colon, and then let's indent. Something else I should add is that in Python, we do not use curly braces for indentation purposes. We use colons and the tabs. So right now, what we are doing in Python is essentially pressing tab whenever we want to go to, I guess, a next indentation of code in order to tell Python that we're inside the for loop now. So what we're going to do here is print I. What this is going to do is going to print the numbers from 0 to 9. And it's very important here to realize that it only prints from 0 to 9. So why don't we run this? So the reason why it only prints 0 to 9 is because when you pass in one argument in a range function, it treats that argument, it's sometimes referred to as the end value, as exclusive. So it essentially goes from 0 to 10, but 10 is exclusive. So it essentially goes from 0 to 9. But we can pass in more than one argument. If we pass in 2 arguments, we can make the first argument the starting index and the second argument the ending index. So why don't we do that, Alex? Let's create a loop from 1, 11. And this is because the starting index is inclusive. So whatever we put as the first argument, it will include that. But the second argument is essentially the endpoint. And the endpoint is always exclusive. Throughout today, we're going to realize that a lot of the functions built into Python with this idea of an end condition, like this range function, usually it is exclusive. So as you can see here, this for loop can be easily ran using this range function. And this is how most people do run for loops. So if I want to run a for loop through the length of a list, all we have to do is run this range function through however long that list is. If we don't know how long that list is, we will talk about it a little bit later on how to access some of those. But for now, we're going to talk about how we can change this for loop to be a little bit more Pythonic and print it all in one line. As we showed earlier in the PowerPoint, we are able to actually run these for loops all in one line in order to print everything. All we have to do is use the asterisk operator. Now, this is kind of a new feature in Python that many people are unaware of or don't really exploit much. And what it essentially does is that it expands an iterable or a list or a string, etc., with a space in between and print it. So why don't we do that, Alex? In order to use the asterisk operator, we write print, and then we use the asterisk, and then we pass in the iterable. So in this case, we are running a range iterable. So let's do range from 1 to 11, just like last time. And if I want to print it on one line, I will have to do, well, I don't have to do anything actually. So let's run it to kind of show this off. Yeah, I don't have to do anything. And that's because there's this implicit argument being passed here that many of us don't see. So if we do slash inside the print, after range, we do, my bad, not slash, comma, my bad, comma, SEP, which stands for separation, is equal to, and what we do here is we can pass in an argument to indicate how we want to separate these items. So implicitly, what's being passed in here is a space. So if we just leave a space here and run it, we're going to see it's going to give us the same exact thing. I think Alex did run it. And as you can see, oh, did you just run it? Okay, yeah. So he ran it. And as you can see, it runs the same exact thing. But what we can do is we can pass in a different separation value. If, for example, we want to print it on a new line. So why don't we just do \n in there? And just like Java and C, there's new line characters in Python. So let's run this. And cool, we are able to print this iterable, or basically run a for loop just like we did before, all in one line. Really nice. Now let's talk about list and string manipulation. I kind of talked a little bit about lists and when I was talking about iterables. In Python, there's no idea of an array. Like the idea of an array isn't really there. Instead, everything is planted inside these items or these data structures called lists. And if you've taken a CS1 course, these are essentially array lists. And if you ever code in Java, you might be familiar with the array list library. In essence, Python utilizes array lists for everything that would usually utilize an array. And for those who are unfamiliar with the differences between array and array lists, essentially array lists can always expand and shrink in size, and you can easily append and remove elements from them. So why don't we talk a little bit about list and string manipulation in order to explore this concept? So the first prompt we have here is to initialize a list of 10 elements and try to call an index. So if any of you have ever coded in Java, for example, you will realize that in order to initialize a list of elements, it's really simple. All you do is you call the array list, presuming you are using the array list class, and you pass in 10 to indicate its size. Well, in Python, you can't really indicate its size, but what you can do is you can fill it up. So in order to fill it up, usually what you would do in Java is you would run a for loop and you would pass or fill it up with a certain value. I believe in Java, it automatically gets filled up with the number 0, but in Python, that doesn't happen. So why don't you try to show us this, Alex? So let's run a list and let's call it array list to kind of hint at the similarities here. And in order to initialize it, all you do is use these square brackets to indicate a list. Now I can't pass anything inside the list because that's essentially initializing it with values. In order to declare it is size 10, what many of us do is that we multiply the array. Yes, you can multiply data structures in Python. And what this essentially does is that it creates that many instances of it together. So if we multiply by 10 here, what this is doing is that it's creating an array 10 times and just conjoining together. So it's essentially an array of size 10, but this is not exactly true. So why don't we print a certain value, Alex? Let's print array list at index 3. And similar to C in Java, we can use the square bracket notation in order to access values at a certain index. And as you can see, an error occurs. Because although we are creating an array list, or I should say a list of size 10, there's nothing we're passing into the list. So it's going to at every index and saying, why don't you plop in a blank there, a blank there? Well, at that point, Python doesn't even make the list because you're not giving it anything to plop into those indexes. So instead, what we have to do is that we have to give it a value to put into those 10 spots. So let's pop in a 0. So now if we run it, we're going to see it's going to return us a 0 at index 3. And indeed, it does have access to index 0 to 9. And let's prove this. In order to prove that this list is of size 10, we can use a function called length, L-E-N. Print, why don't we print this out, Alex? What we want to do is we want to print, we write len as a function, and we pass in the list. This is not an attribute. This is just an outside function call by passing in the list. So if we run this, Alex, what we're going to see is that it gives us 10 to signify that the list is of size 10. And just like I hinted earlier, this function is really useful. You can use it in your for loops. If you go onto line 10, Alex, just hover over line 10, you see where it says range 1 through 11. Many people just put in range length of list inside the parentheses in order to indicate essentially a loop throughout the list. So we can comment that out. This is just good notation for future use. Cool. Let's go back to list and string manipulation. So why don't we talk a little bit about, let's talk about, let's work with this mixed list problem here. So if we were to go down to this practice problem, because we kind of did the other ones below, it says separate this mixed list of numbers into an even list and an odd list. Now, if you look at this list of numbers, you will see that the numbers are 2, 4, 6, 1, 3, it should be 5 there. Yeah, 1, 3, 5. So obviously the first 3 values are even and the second set of 3 values are odd. So if we were to do this in Java or C, what we would do is that we'll just run a for loop to 3 and then make that, put all those values in its own list. And then we create another for loop from indexes 3 onwards and put all those values in another list. However, in Python, we can do this really easily with something called slicing. So why don't we kind of demonstrate this with print statements, Alex? If I was to print right now, mixed list, and I use a bracket or interval note, square bracket notation, usually if I just pass in one value there, let's say I pass in 0, what that does is that it prints whatever is at 0. However, I can make it print more than what's at 0. If I print 0, colon, let's put a colon, and then we pass in another value, let's do like 3, for example. What this does is that it slices the array into a new array from index 0 to index 3. So theoretically, in the background of Python, for those who want to get into nitty-gritty, this is creating a new list. This is extra memory, but it's really convenient and really nice that we're able to essentially create a new list using this notation really simply. In order to prove that this works on the other side, why don't we make another print statement below that, Alex, and to print from index 3 to index 6. So why don't we run that? And as you can see, from the first print statement, we're able to get all the even numbers, and the second print statement, we're able to get all the odd numbers. Sorry. So this is really easy, but there's even more shorthands that are applied here that we can apply here. For example, what happens if we don't pass in a value? So this is very intuitive on the first print statement on line 29. Most people will want to presumably print from the first index to somewhere else. So Python gave us this extra feature where if you don't put any number in the thing to the left of the colon, it essentially implies 0. So if we run this right now, even though we have nothing to the left-hand side of the colon, Python assumes that it is a 0 because it's on the left-hand side, and most people will put 0 there. This logic also applies on the right-hand side. So if we go on line 30 and get rid of the 6 there, most people will assume that the right-hand side, they want something from one index all the way to the end. So if you don't put anything in the right-hand side, in the background of Python, what they're plopping in there is the length of mixed list. And the length of mixed list happens to be 6. And remember, the second index is exclusive. And as a result, it prints the rest of the list. So these are just some nice slicing tools that make coding in Python very Pythonic in a way. Now, these techniques can also be applied to strings. So why don't we work with these string values, Alex, in order to separate this string from race and car? So why don't we use those same techniques? Let's run a print statement from string, for string. We call it string. And if we can tell here, we don't have to pass anything in the first index or for the first argument, but race car, the word race is at the 4th index, I believe, exclusive. So why don't we go from blank to 4 and run that? And as you can see, we get the word race. And let's also do the same for car. So this is, yeah, let's comment those out. It's going to be print string for onwards. Great. While Alex is doing this, an important lesson to have here regarding strings and how they're a little bit different from lists and other languages is that strings in Python are immutable. Unlike languages like C, where strings are practically char arrays, in Python, you cannot change the value at a certain index of a string. So for example, Alex, to show this off, why don't we try to assign string, let's do the interval notation, and let's give it an index. Let's do 0 is equal to, and then let's assign it like T, taste car. If we run this right now, it's going to give us an error, and it says string object does not support item assignment. And this is one of the inconveniences of Python, to say the least, that string objects are immutable. Rather, exploiting slicing, this ability to get a large portion of the substring really easily, we can instead, as opposed to changing the string, we can just make a new string. And this is how many people utilize string and use string manipulation in Python. So let's do that. So under these print statements, Alex, let's write the word taste car without manipulating the string variable itself. So in order to do this, what we're going to do is we're going to print, let's print, print string from 1 onwards. So we're going to use the square bracket notation from 1 colon onwards. So this gives us the substring ace car. And at the beginning of that print statement, Alex, why don't we give it the string T? So let's use the brace. Let's make it a string. I forgot what those are called. Quotes. Yeah, I think the quotes. Let's make the letter T quote. Yep. And then let's run this. And what you see here is that we're able to create the string taste car. Yeah, this bottom thing is still giving us error, but we're able to create the word taste car without manipulating the string itself. Instead, we just created a new string in essence. We created this new string of T, and then we created this new string of ace car and just plopped it together. And that's kind of how string manipulation works. Now, let's talk about one cool trick with string indexing, or actually just indexing as a whole in Python that other languages usually don't have. And that is printing the last letter or the last index. So why don't we code up how this would be usually done? Alex, let's write the word print and then string. And then inside the square brackets, many people in other languages, and some people still do in Python, they would write length of string -1. And this makes sense. If you want to print out the last index of a certain value, or a certain list or string, it is assumably going to be, or presumably going to be, the last index or the length of the item -1, and that correlates with the last index. However, this is very long and verbose. So instead, what we can do in Python is we can use a special number. The number is -1. In Python, there's negative indices. I'm not going to get into the nitty-gritty of how they work and kind of the idea behind them. But what you essentially want to remember for most of your, for when you are coding Pythonically, is that the -1 index in particular refers to the last item in the list. And utilizing this feature, we can very easily print the last item in a list or a string really easily in a lot less code. Cool. Now let's talk about dictionaries and sets. So dictionaries and sets is a common data structure that most people learn when they first get introduced to Python. And the reason for this is, as we've seen so far, Python is a very nice language to write in. The code is very maintainable, it's easy to read, and with the proper tools, you can reduce the amount of code you have to write a lot. And with this, it makes it a very attractive language for data science and other, I guess, subfields of technology where you might be using a lot of data structures, in particular dictionaries. So as a result, Python has a lot of support for dictionaries. And for those who don't know what dictionaries are essentially hash maps in Java. And for those who are taking or about to take the foundation exam, or for those in CS1, the abstract idea of hash maps, this is basically what it is in dictionaries. In order to initialize a dictionary in Python, let's call it dictionary. Let's make the variable name dictionary, Alex. All we have to do is we have to assign it to curly braces. So to recap, arrays, or I should say lists, are square braces. Dictionaries are curly braces. And what we can do is that inside a dictionary, just like a hash map, we can assign key value pairs. And what these essentially mean is I can pass it in a key, think of it as an index, and appropriately, I can assign a value to that key. So for example, let's create a dictionary of all the tech leads' favorite food, or actually let's do our favorite number, okay? In order to do this, we're going to create a dictionary with the key value pair where the key is our names and the value is our favorite number. So Alex, why don't you write Alex as the key here? And then after you write your key, what you do is you use I think those are called colons, in order to assign its value. So Alex is going to assign a number. So let's not use a string here, Alex. Let's just assign it an integer number, your favorite number. You can choose Alex. Okay, Alex likes the number 21. So now if we, under that dictionary, we write print dictionary. And then what we do is we use the square brackets, kind of like how we do with lists. And inside it, and as opposed to passing in a number as the index, we're going to pass in that key, and that key is Alex. So why don't we run this? Something that Alex just did here that we didn't go over is that you can initialize strings with single quotes or double quotes. I forgot to mention that earlier. That's my bad. So as you see here, Alex initialized his name Alex in the dictionary with double quotes, but he called it with single quotes on line 45. But even then, they both produce the same string. They both work the exact same way. And as you can see from that print statement, it printed the number 21. It treated the key Alex as an index, essentially. And that's very useful. Alex, why don't we show that this dictionary works with more values? So let's add some more values in here. Why don't we do comma Ryan for me? And then my favorite number is, let's do 8. And let's print my number in the dictionary. So let's run it. And cool. You can see my number there printed in the terminal. And this is in essence how dictionaries work. With dictionaries, there are also these ideas of sets. And they're the same concept as a dictionary, except there's no values attached to the keys. So for example, if I only wanted to put in a list of all the members in the DSC, this would be a set. I don't want to assign any value to our names. I just want to create a list of our names, Alex, Ryan, Max, etc. But why would you use a set? For those who have not taken CS2 or who are unfamiliar with this, sets have an O of 1 lookup time. So essentially, it's just faster than a list. And we can very easily check if something is inside a list of items using a set instead of a proper array list in essence. So how do we initialize a set? Let's create a set called hash set in order to symbolize the similarity here. And we set it equal to the word set. Yeah, you can also initialize it like this. Alex is right. You can declare it like this. This was my bad. You can declare it like this using the word set with an open parentheses and close parentheses. And underneath that, Alex, yeah, this is similar to hash set. Yeah. So if you go underneath that, we can do set or hash set dot add, and we can just add the values here. So let's add Alex. And then let's underneath that, let's do hash set dot add Ryan. So we're only going to add us two for now into this set. So let's do that. And underneath that, we're going to call us from the set. So obviously there's no values attached to our name. It doesn't, Ryan isn't attached to the number 8 representing my favorite number. It's just Ryan. So instead, I just want to return a Boolean if I exist in the set. So in order to do this, let's write print Ryan in hash set. And as you can see here, we are utilizing this in keyword again to kind of symbolize, go through that iterable. And as you can see, it returns a true because I am in the hash set. Let's prove that this works with something that is not in the hash set. It will return false. So let's put Max. Max is not in that set. And let's run it. And as you can see, it returns false, indicating that Max is not in the hash set. Really cool. So this is kind of a base introduction, a proper introduction to Python and most of the tools that many people use, and kind of a sneak peek in how to code Pythonically. We're going to now use these tools and more tools that were not featured here to code up a Hangman game. And for many of you who are unfamiliar with the Python language, when we code up this Hangman game, many of you will realize that there are some code snippets that you don't understand, or there are some things that weren't really explained proper, and that's totally fine. What we're going to do is we're going to give you this code after the event for many of you to go through it. And we are also going to talk about what each code snippet does, with the exception of one. So you can always come back and refer to this when you're slowly learning the language and how to properly code Pythonically. Indeed, it wouldn't be a proper Python workshop if we don't code this Hangman game Pythonically. In other words, as simple and exploring the benefits of Python to the fullest. So let's go into a new REPL, Alex. So let's create a new REPL, yeah, in Python. And feel free to code along or just to watch this as Alex codes this up. We will also send the code for the Hangman game after this event. So feel free to always look back afterward if you decide you want to code this by yourself or something along those lines. So in order to code a Hangman game, we're going to code it inside our terminal. So when you are kind of tasked with this, there's 3 things that you kind of got to think about. You got to think about one, where's the word bank? You got to get a bank of words that the Hangman is going to push out, and how you're going to read those words. You're also going to think about, also going to have to think about, how do I make the Hangman? For the sake of us, we're going to make it in terminal. So we're going to use some cool ASCII art or just some cool strings in order to make a nice looking Hangman. And one of the last things you have to think about is, what is the logic of the game? What are some terminating conditions? So when does a Hangman die, or when do you win? And simple things like that. We're going to approach these 3 main things one at a time. So the first thing we're going to approach is, where are words? So Alex, why don't you create a new text file? we're going to create a text file on REPL, which is really easy. All you have to do is click the add file button on the top left, and let's just name it like words.txt, for example. And inside there, why don't we just put out like 10 words, just for demonstration purposes of the words that we might add to have for our Hangman game. You can put words like, let's put Epcot. That's a good word. Let's do red. And then let's put like Google as one word. And then developer as another word. We'll put student as another word. Club as another word. Let's see, it's three more words. Let's put your name, Alex. Let's put just Alex. Okay, let's get sushi. Okay, two more. Okay, let's put Python, just for the sake of this workshop. And then let's put one more word, Pythonic. Cool. So now what we're going to do is that we're going to start going back into the terminal and thinking about the second step, which is how our hangman is going to look like. So in order to make a hangman, I think the easiest way to do it is to create a list. Okay, I don't know what that was. Let's create a list and let's call it hangman, Alex. Let's create a list. And inside this list, what I want to do is I want to create multiple strings that represent each level of the body. So for example, why don't we print out what theoretically the top level of the little hanger that the hangman looks like is on. So in order to do this, using our ASCII art ideas, we're going to put a space, Alex. We're going to put that little L character. We're going to put a bunch of dashes, however much you want. Okay, and then we're going to put another L. Okay, and then we're going to put another string in here. So let's do comma. And then let's put another string. But this string, theoretically, if we were to think of all these items as a hanger, it's going to just be another L. It's going to be a couple of L's, Alex. Why don't we add like 5 more L's maybe? Yeah, nice. And then let's add one more L, but at the bottom L, we're going to have 2 little underscores on both sides to kind of indicate the bottom of the pole. So as you can see from the terminal or just a coding editor right now, it looks like a hangman thing. In order to prove this, we have to print out this list of strings. And if you remember, using our unpacking operator, the little asterisk operator, we can do this in one line. What we're going to do is we're going to print asterisk hangman. And then remember, we want to put these on a separate line. So if you do comma SEP, usually this is initialized to a space, implying that all these strings are going to be printed with a space in between. But we don't want that. We want all these strings to be printed on a separate line. So the separation is going to be \n. So let's put that and let's run it. Cool. We have a little hanger for our hangman to hang on. The next thing I want to do is I want to think about how am I going to add the body parts to this hangman. This is going to be a little bit hard because if you think about it, what we want to do is we want to print the hangman array, but instead I want the strings to be a little bit different, implying or based on how many words they have gone wrong. For example, if they got a wrong guess or just one wrong letter guess, I want to give them the little head to indicate, they got that part wrong. But if they didn't get any letters wrong, I just want to print out this pole without the little head. So what we're going to do is there's many ways to approach this. But one of the ways we can approach this is that what we can do is we can create a separate list signifying the body parts. So let's do that. We're going to create a list called body parts. And then we're going to assign it to all the body parts. So let's make an O for the head. Let's use a this thing. Yeah, that for the left arm. And then we're going to give it a line to indicate like the downwards body of the hangman and a right arm. So yeah, that. Now, remember, this is technically an escape character. So just like in Java and C, you're going to have to type this 2 times, this backslash thing, or forward slash, I'm not sure. And then comma, we now got to do the left leg. So it's just going to be a slash thing. And then the same 2 backwards or forward slashes for the right leg. Cool. So now if we go to our hangman, what we want to do is that we want to change our hangman array to have manipulated strings with all of those corresponding body parts. How do we do this? What we're going to do is we're going to use a special string method or function called .format. Why don't you make the string larger, Alex? So yeah, let's add some spaces. And then let's put a curly braces. I think those are what they're called. Yeah. And then after the string, Alex, let's type the function .format. If any of you have coded in the language C, you will remember these percent signs when you print something using printf. I forgot what they're called, but what you can do, if I remember correctly, is that you can pass in arguments to those percent signs in your printf, and appropriately, those arguments will correspond to those percent signs. And this is the same idea here. So in here, what we can do is that we can .format, we can pass in certain variables, and what they will do is that they will be placed into those little squiggly brackets. So why don't we pass in body parts 0 to indicate the O shape element. So let's run that to kind of show off how that works. And as you can see here, on the second level, the string is formatted correctly to place in a letter O where those square or those curly braces are. Now let's do the same for every level. So on the second level now, we're going to have 2 squiggly braces, and that's because we have a left arm and a right arm. So in order to do this, all we do is just put 2 squiggly braces. I think the dot format's in the wrong spot, Alex. You have the dot format to the right of the, yeah. So let's put it on the, yep. So we do dot format. All we do now with 2 squiggly braces is we pass in body parts 1, comma, body parts 2. So format can take in an appropriate number or the correct number of arguments corresponding to your string. So in this case, there's 2 arguments that the string wants. So dot format will take in 2 arguments. Really nice. So let's do this for the 3rd and the 4th level. Let's just, or is it just one more level? Yeah, just one more level. We just got to print out this dude's legs. Yeah, let's put a space in between. That's a nice idea. Let's do dot format, body part 3 and 4. Yeah, let's make the other one 4 on the, yep, and let's run it. Cool, now we have a full hangman, but now we have a problem, because if you think about it, now your hangman is gonna be printing all these body parts, but how do we tell him only print the head if they've gotten 1 wrong, only print the head and the left arm if they got 2 wrong, etc. And in order to do this, what we're going to do is that we're going to be using a counter variable for 1. So let's make a counter variable, Alex. Let's assign it to 0. And what this counter variable is going to tell us is it's going to tell us how many words they've gotten wrong. So let's just initialize it to 0 to indicate that, hey, you got zero letters, or I guess when you play Hangman, you're not guessing words, you're guessing letters. So you got 0 wrong letter guesses, okay? But at each extra letter guess, I want to change the hangman array to have the appropriate body part. So if counter is 1, I want to print just the circle. If counter is 2, I want to print the circle and the left arm. In order to do this, I can create a bunch of if statements, or I can use some cool slicing tricks. So let's use some cool slicing tricks. what we're going to do is that we're going to create a new list. We're going to call it temp body. And what temp body is going to do is that it's going to use the cool multiplication trick where you can multiply arrays in order to create a proper list with the correct number of body parts attached. I'm going to do less talking and more coding here. Alex, why don't we write temp body is equal to body parts, and then we're going to give it a square brackets. We're going to put nothing in the first interval. We're going to put a colon, and then we're going to put counter as the second interval. What this does is that it's going to take the body part that, that belong in the new Hangman. So for example, at this point, it's going to take body parts from index 0 to index 0. Essentially, it's not going to take anything from body parts. It's going to be like, hey, take nothing from body parts, and then plus, let's put a plus, Alex. We're going to concatenate that with a bunch of empty, an array of a bunch of empty elements. So in order to do this, if we remember correctly, all we do is we pass in the string that's empty. So it's just string with a space. And we multiply that by what isn't filled in by counter. So which is the length of body parts minus counter. So to reiterate, what this function or what this temp body list does is that if you, for instance, have 2 wrong letter guesses, it's going to take the first 2 elements of body parts, which is the head and the left arm, and it's going to fill the rest of it with an empty space. Now with this, what we're able to do is that in our Hangman list, we're able to change body parts now to temp body, because temp body will always be updated with the correct values, whether that be a space if they don't have a wrong guess, or a body part if they do have a wrong guess in that position. So with this, Alex, why don't we go to body underscore parts in the Hangman list, everywhere that says body underscore parts, let's change that to temp body. Yep, so let's use some Command D action here. Cool. Now let's put all of this in a, yeah, we can run this now. So let's run this actually. Let's show them. So if we run this, right now counter is 0. So this guy hasn't got any wrong letter guesses. Let's put 1. And let's run that. Boom, this guy got a head. He made 1 wrong letter guess. Let's put 3. Let's show them. And boom, this guy's almost dead. So as you can see, the counter variable is now adjusted to the temp body array very nicely, and we can easily create hangmans off of it. So in order to do this, or in order to print our hangman throughout our hangman game, let's put all of this inside a function. So in order to define a function, we use the keyword def. It's shorthand for define. And then what we do is that we give it a function name. So in this case, let's call print underscore hangman. In Python, we use underscores to signify a separate word. I know in Java, we use something like camel case, where the second word is capitalized. For now, all we're going to pass in for print hangman is the counter variable to signify how many wrong guesses they have. And that's kind of it when it comes to initializing a function in Python. All you do is you write the word def. You always add the word def. You give the function name, and then you give in the arguments you want to pass in. No types, no return types, or no return, whether or not it returns or not. No static, nothing. It's very simple. So as you can see now, we are able to create our hangman using this function. So in order to prove this, let's go under line 17, Alex, and let's just call the function. Let's do print hangman, let's say like 2. Let's do 2 this time. Yeah. So just pass in the number 2. Yeah. And as you can see, this guy got a head and a left arm. And whenever we are going to call this function, we're going to want to call it with the counter variable, obviously. We're not going to want to just pass in a normal value, but it's really nice to see that this function actually works. So now, the next thing we're going to do is that we're going to think about how we want to grab the words from our like bank of words. So words.txt. I'm not going to teach you guys all about file IO and parsing through all of this text, because I feel like it's very little opportunity cost with that, with going very deep into file IO and talking about how to grab a random line in this file. So instead, if you look in the REPL I sent all of y'all earlier, so go into the REPL, Alex, there is a text.txt in there. So why didn't you open that? And this is just, if you look into text.txt, we have a function called random line that just grabs a random line from the file. This is optimized. I can assure you it's optimized. And just plop it into the Hangman game code. So this is going to be the one snippet of code I won't talk too much about. But it essentially grabs a random line from the file when you pass in a file name. One thing to note about this, though, is it does use random to signify a random line. So we're going to have to import random. So why don't we just import random, Alex? Nice. So now let's go back to the bottom here. And then the next thing we're going to do is that we're going to open the file. So we're going to do file is equal to open, and then the file name. This is very similar to how it is in Java and C. You just use like fopen and C, and I think you just do file.open in Java. I'm not too sure. Don't quote me on that, but it's very similar to syntax. You just open it, and if we don't pass in any arguments, this is presumed to be read only. So we want to read only, so we don't give it any more arguments. The next thing we do then is we write random word. We can make a variable called random word, and we assign it to that, that function we just plopped in there. So the function is called random line, and we're going to pass it in the file name. Now, when we do this, let's go back into words.txt. When we do this, one thing we're going to note is that if you learn a little bit about how text files or how these words actually look like in text files, this isn't just simply the word epcot on line 1. It's actually the word epcot\n. So when the file IO is passing in these lines, it's going to keep the \n. So one thing we have to do is we want to get rid of it. So in order to do this, what I'm going to do is we're going to go into main.py. We're going to go back to our function. And we're going to write if, under that, we're going to write if random word. So remember, random word at this point is a list of word, is a word. So it's a string, -1, indexed at -1, because if you remember earlier, -1 indicates the last letter of the string. So if the last letter of the string, -1 index, equals, this is the equality operator in Python, \n. So let's signify \n. Then what we're going to want to do is we want to remove it. So what we have to do, remember, we cannot manipulate strings in Python. Instead, what we have to do is we have to create a new string. So we're going to do random word. We're going to essentially reassign it. Random word is equal to random word. And then we're going to give it the slicing properties again. So it's going to be square bracket, nothing or no element. So from the very beginning to -1, so the last index. And remember, the second argument is exclusive. So this is going to exclude the last letter. Some of you may ask, why are we putting this inside an if statement? Like, why are we checking if the last letter is \n? Isn't it always \n? This is not true. If you look back in the words.txt file, the last word, Pythonic, does not have a \n because there is no line after line 10. So as a result, we have to have that if statement. It's kind of redundant, but that's why we have the if statement, to ensure that we are deleting the last letter, and that last letter is indeed a \n. So now what we're going to do is that we're going to start thinking about how we want to code up the terminal game. When we want to code up a Hangman game, there's a couple of elements that go into it. One, it's the Hangman itself. We have that working. The second thing we want is we want to have a output of the number of letters, or just a bunch of dashed lines to signify all the letters in the word. So for example, if me and you were playing Hangman together and I wanted to put the word Epcot, I'll draw the little Hangman thing and I'll write 5 dashes to indicate the 5 letters in the word Epcot. We're going to make those dashes in a list. So why don't we create a list, Alex? We're going to call it guess. And this variable guess is going to signify the current guess that you have on the board if we were to hypothetically play this game in real life. And presumably, it's going to be filled with a bunch of dashes in the beginning. So we're going to do a dash in there. So in order to do that, we just make a string with an underscore to signify, the little dashes. And then we're going to multiply it. We want an equal number of dashes as an equal number of letters in the word I'm guessing. So for example, if I wanted to make you guess the word Epcot, I'm going to add 5 dashes. So in order to signify this, I'm going to do length of random word, because presumably at this point, the word Epcot is in random word variable, in the variable random word. And those are all my dashes. So now, Alex, why don't we delete line 27 where we print the Hangman. Okay, and then what we're going to do on line 36 is we're going to print the Hangman. So let's print the Hangman. So let's run the print Hangman function to signify the Hangman. So let's run print Hangman. Let's presume they have 0 wrong. Let's just pass in counter. This is how we'll probably run it to signify that they made 0 wrong guesses at the very beginning. And then I want to print out the guessed, the guest list with a bunch of their, the dashes. However, in order to do this, I want to separate these little underscores with a space just so it's more readable. So let's use the asterisk operator again. We're going to do asterisk guess. Yeah, now we don't have to use separation because remember, if you don't pass in the separation operator, it presumes a space. So if we just run this, let's run this, Alex. Is it not stopping for you? Okay, there we go. Something's wrong with your terminal or something?
I guess it's my connection, actually. I don't think it has to do with Replit.
Is it not printing at all?
No, it's my connection. Actually, let me reload the page.
Oh, okay, I see.
Okay, it printed something. Not what I want to see.
Okay, let's try running again.
All right, yeah.
Cool. This is presumably one of the words from the words.txt file. We don't really know, but if I was to guess, I think that's the word Pythonic, if I was to guess. It doesn't really matter. At least we know that this is what our setup is going to look like. Really nice. So let's delete line 37 and 38. This is just good to know. And then the next thing I want to do is I want to also create a word bank. When we are playing Hangman, every time someone makes a wrong guess or a right guess, they can easily look at a word bank of the previously guessed letters so they don't guess the same thing again. So I'm going to create a word bank, which is not going to be the same thing as the .txt files. I should actually specify this. This should be a letter bank in essence. It's a bank of letters they've guessed, right or wrong. So what we're going to do is we're going to name this variable guessed letters. So let's do guessed underscore letters, and we're going to make this a set. So it's equal to set. And if you remember earlier, I'm only making it a set as opposed to a list just because it's a little bit faster. Yeah, cool. And then the next thing I'm going to do is I'm going to initialize another variable called guessed length. And guessed length is going to keep track of how many letters I've guessed correctly in the full word. So for example, in the word Epcot, there's 5 letters. If I guess the letter E, guess length will be 1 to indicate I've guessed 1 out of the 5 letters in the word Epcot. Cool. Now we're going to make our while loop. And this while loop is going to encompass the entire game. And it's going to keep running as long as the user has either A, not lost the game, and B, not won the game. So how do we identify whether or not someone has lost or won the game? We're going to make this the condition of the while loop. So in order to do this, what we're going to do is we're going to do while, and it's going to be counter is less than the length of the body parts. Because presumably, if they were able to guess make 5 incorrect guesses, then their counter or the length of the body parts is equal to counter, which is 5, and this condition will be false. And second of all, and you can use the and, the keyword and in Python, not two ampersands. You use the word and. Guess length is less than the length of the word. So, for example, if I guess just the letter E and the word Epcot, the game will continue running because I haven't guessed all the letters. But if I've guessed 5 out of 5 letters, guess length will equal random word, and thus the while loop will exit because I won the game. So these are the two conditions. Counter is less than length of body parts if I lose, and guess length is less than length of random words if I win. Cool. Now let's create the while loop conditions. What we're first going to do is we're going to create another function to clear the screen, because every time they make a guess, I don't want all these ASCII and all these letters to just clump up with each other. So why don't we create another function? Let's create it outside of the, let's create it outside. Let's call it def clear screen. And what we're going to do is we're not going to pass anything into clear screen. It's just going to be a normal function, and it's going to print a bunch of new line characters to basically clear my terminal screen. This isn't the best way to go about this, but it's nice. It's simple. Multiply that by 500, Alex. Just a really big number. So now this is essentially printing 500 new lines. A little bit unnecessary, but I'm sure it's enough to clear the terminal screen. And then every time I want to clear the screen, I also want to print the hangman. So let's print the hangman, just like we did earlier. And let's pass it the counter, but also let's pass it the word bank. Why don't we do that? So the word bank is guessed letters. Yep. Let's go back up to the print hangman function and give it the guessed letters. And inside the hangman function, why don't we print the word bank before we print the hangman? I think that's a very nice feature. So we're going to go underneath here. We're going to use the unpacking operator in order to print guessed letters, which is a list of guessed letters in one line. So it'll be asterisk guessed letter, or guessed letters. And we're going to make, And then after that, I want a new line character. And so I would use the keyword end is equal to, let's just give 2 new line characters just for simplicity. And for those who have never seen this before, what I'm essentially doing is I'm printing guessed letters all on one line. And then it's as if I just made 2 print statements below that. So I did print guessed letters, print, print. And I can represent that by using the end keyword, which basically says at the very end of printing all the letters in the word bank, print 2 new line characters. Nice. Now let's go back down to our our clear screen. One last thing that I want to do when I clear the screen is obviously print the guess that they have made so far. So to reiterate, it's going to print a word bank or a letter bank of all their guess letters. And then it's going to print the hangman. And then lastly, what it's going to do is that it's going to print their current guess. So in order to print the current guess, all I have to do is asterisk operator, guess. And let's also use the same end keyword in order to add a new line character after I printed their guess. Nice. Now let's go into the while loop. What I'm going to do now is going to ask for an input. So let's ask for an input. We're going to do use a random variable. So let's just write like next guess. And in order to ask for input in Python, you use the keyword input. So if you were to make analogies to C in Python, this is just your scanner.in in Java, or your scanf in C. This is more so like fgets, to be honest, though, than it is scanf. What it does is it just reads everything past it, very similar to fgets. Although fgets does a line, it's kind of the same idea. And what I can do is I can pass in a string into input to basically signify what is the prompt that I want to give whenever I'm reading the input. So why don't we give the prompt, guess another letter, to signify to the user, hey, why don't you guess a letter for me to register as a guess for this Hangman game? Also, what we're going to do is we're going to use dot lower, because if the user puts in like a capital A, there's no capital letters in words.txt, so I just want to lower it so I can actually, utilize some of my algorithms to check that they've put in the right word. So why don't we run this, Alex? Let's make sure our clear screen thing is kind of running or working now. Make sure there's no errors. Great. Right now, we can't see the word bank because there's nothing in the word bank. Why don't we add something in the word bank, Alex? Why don't we go up to the guess letters? So on line 38, line 38. Yeah, underneath that, why don't we do like guess letters dot add and then put like a letter that we've guessed before. Let's pretend we guessed the letter A. So let's just pass in A. You want to pass in as a string? Yeah, cool. So why don't we run this just to double check that our letter bank works. Cool. And as we can see, we have our letter bank at the top. Presumably we've guessed the letter A. We have our hangman, or little hanger that our hangman hangs from. And then we have a bunch of letters to signify that the word we're about to guess has 5 letters in it. Cool. Now let's do some verification or do some, I guess, double checking to ensure that the word that, the letter they just guessed hasn't been guessed before. So if we go back to line 49, if I was to be given the word Epcot and I guess the letter E, and then in the next round, I guess the letter E again, well, it's kind of redundant. I know that E has already been guessed, but we want to just ensure that the user doesn't do this. So we're going to just run a simple while loop. So we're going to write while next guess in guessed letters. So if the guess they just made is in the set of letters that they've already guessed, well, we're going to tell them. So why don't we run a print statement? We're going to tell them, you've already guessed, next guessed. And in order to do this, I have to pass in another variable again. So usually we're going to use the dot format, remember, to pass in a variable. But there's even an easier way to do this. You can just put an F at the beginning of your print statement. And this is the same thing as doing dot format. And as opposed to passing in the variable anywhere, I just pass it inside the brackets. So in this case, I want to print next guess to signify, hey, you just guessed this letter, which you've already guessed before. And then what I want to do is give them another chance. So whatever is on line 49, Alex, I just want you to print that and plop it down on line 53. So yeah, just plop it there saying, hey, guess another letter. And it's just going to keep running the while loop as long as, they give me, until they give me a new letter that hasn't been guessed before. Now, what I'm going to do is I'm going to see, and in all of the letters, or in all of the letters of the correct word, how many times does that letter appear and where? For example, if I was to get the word, let's see, what's a word that has two? Okay, race car, for example, race car. Race car has an R at the very beginning and at the very end. Yeah, that's it. So as a result, I want to see, where do I fill in the letter R's? I want to fill it in at index 0 to indicate there's an R there, and at index, the last index, so -1 to indicate the last index. And there's a really nice Pythonic way to do this, to get all the occurrences of a letter in a list. What we're going to do is do some list comprehension. So let's make what we're going to do is we're going to create a variable. Let's call it correct indices. And this will be all the indices where the letter does appear. So in case of race car, it will be index 0 and index 7, I guess, or -1, however you want to think about it. What we're going to write is I, for I, comma letter, in enumerate random word if letter is equal next guessed. I know this looks like a lot, but the logic is very simple here. What this is doing essentially is that it's saying run a for loop in there. And what the for loop is doing is that at each instance of the random word, so basically at each instance, at each letter of the correct word, I want to check if the letter that the user just guessed is equal at that index. If it is equal, I'm going to save it in I. And that's what that I before the keyword for is doing. It's basically holding all those I's or all these indices, all those indices in which those two indexes correlate. You can learn a little more about this by just looking up Python list comprehension. It's a really neat feature that many people use in order to perform Pythonic, clean, concise code. So now what we're going to do is, because we have all the indices that correlate with where the correct letter is, we're going to make a simple for loop. So we're going to write for I for I in correct indices. So what this is saying is go through all the correct indices. This is basically a for each loop, attach it to the letter I. And then what we're going to do is that we're going to say guess, because guess at this point is a bunch of underscores. What we're going to do is make it the guessed letter they just guessed. So which is assigned to next guessed. And if any of you are getting lost at any point, feel free to leave a question in the chat. But more importantly, this code will be posted after the event. So guess I is equal to next guessed. Yeah, this is a next guess, correct? And then what we're going to do is we're going to increment guessed length, because theoretically, they just guessed another letter in the word. So plus or equals 1. In Python, we don't have a plus plus operator. We don't have a minus minus operator. It's very sad. We just have to stick to plus equals and then add a 1. So with that, we're kind of done. This is basically it. The last thing we're going to do in this while loop is to see if they've died or won. Basically, if anything happened, that will terminate the while loop. So in order to do this, what we're going to do is we're going to run an if statement. And if length of the correct indices is less than 1, so basically, if it went through all the letters in the word and they couldn't find a single index of that letter, then obviously you just made a wrong guess. So what we're going to do is if length of correct indices is less than 1, well, that implies that there's nothing. There's not a single correct index. I'm going to increment counter plus or equals 1 to signify I'm going to give you a head, or I'm going to give you a leg, or whatever part of the body like you're nearly dead at. And then I'm going to do guess letters dot add the letter that you just guessed, which is next guessed. And this is just a word bank. Regardless of whether or not the word is right or wrong, we're just going to add it to the letter bank to signify that they've guessed that letter. We're not going to go too deep in whether or not that was a right or wrong guess, etc. Let's just put it in the word bank. And that's kind of it for our while loop. So now let's get out of the while loop. Presumably now, if they made the right or wrong guess, they will be out of the while loop. And we want to do we just want to do a little bit of things. What we're going to do is we're going to clear the screen. So let's do clear screen. Yeah, yep. And the last thing we're going to do is we're going to write if counter is equal to 5. Because if the counter is equal to 5, then, they're obviously out of the for loop or out of the while loop because they've died. So what we're going to do is we're going to print using format printing. So printf. Let's try to do this in one line. You lose. Let's do a sad face. \n Let's do a backslash n inside the string. Yeah. The correct word was, and then let's pass in, yep, let's pass in random word because random word is technically the correct word. Cool. And then else, they won the game. So let's just write else, print, you won with a smiley face. And let's run this and play some Hangman. Hopefully this works. If it doesn't work, we're going to debug it as we go. So let's run this. Oh, we have to get rid of the A. Let's get rid of that. Yeah. Okay, let's stop and guess. So let's cheat a little, Alex. Let's go into the word.txt. Let's try to hypothesize what this word might be. This has how many letters? 6. Python maybe, or Google. Yeah, either one. Just okay. It's Python. Okay, so let's pretend we won this game. So as we see, Alex is putting in all the letters, and we know the word. So a little cheaty, and it tells us we won at the end. At the very top, there's a word bank as we're playing along to show that we've guessed all those letters. A set is unordered, so these aren't ordered in the way. But if we want it to be ordered, we can use a list instead. Just swap the set with a list, it will work. But now let's do what happens if we lose, Alex. So let's just run this. That's definitely a long word. So just put a bunch of letters and then just hope that those are wrong letters. And let's do a Z or something. There's no way it's a Z in there. Alex, are you there with us? Okay, cool. It was just a little lag, Alex, no worries. Okay, and as you can see, once we've made all those wrong guesses, we made a total of 5 incorrect guesses, it's gonna print you lose, and it's gonna lastly print the correct word was developer. And that's kind of it. This is Hangman in around like 30 minutes, I think it took us. It was a pretty quick coding this up. We could even use even more tools to code this Pythonically. This video will be up on our YouTube, like Hannah says in the chat. And if any of you have questions, feel free to leave them in the chat. Why don't we go to the slides really quick, Alex, here. So thank you for coming out to our event. We hope you guys learned a little thing or something new regarding Python at the very least. And if you were new to Python, we really hope this was a really good introduction to it. And we will be posting this code afterwards and all the resources that have been sent in chat. And this will allow you to not only code up your own Hangman game if you want to, but this will also help you learn more about the certain Pythonic coding features that we utilize in the Hangman game. On the screen, there's a feedback form on the QR code there. I will drop this feedback form in the chat for all of you. I believe this is the correct one. Let me double check before I drop it in the chat. Nice, okay, it is. So here in the chat, there's a feedback form. We will be very happy with any feedback. Please submit the feedback form. It is very helpful in planning the future of our events and teaching us about some things that we could do better for future events. Thank you everyone for coming. Okay, I think it's just down to the DSC members now, so I'm going to stop the recording.